Bem-vindos ao 12º Congresso Internacional de Ciências e Tecnologia e Desenvolvimento, CICTED 23. Bom dia a todos, em especial boa tarde para nosso palestrante que está na Inglaterra e, portanto, já são 2 da tarde. Eu gostaria de introduzir, de apresentar nosso convidado palestrante, Dr. Marcos Dieste, nascido na Espanha, em Saragossa. Ele estudou economia na Espanha e fez o PhD, o doutorado dele em operações, gerenciamento de operações na Universidade de Pádua, na Itália. Ele atualmente é professor assistente de gerenciamento de operações na Universidade de Pádua e tem como tema de pesquisa a transformação digital e a sustentabilidade. A palestra de hoje tem como origem uma vasta pesquisa desenvolvida, identificando os aspectos negativos da indústria 4.0. Depois da palestra, abriremos para perguntas dos senhores, portanto, solicito que as perguntas sejam postadas via chat, identificando-se com o nome e área de atuação. Welcome to the 12th International Congress of Science, Technology and Development, CICTED 23. Good morning, everyone, and especially good afternoon to our speaker, who is in England, and therefore it is already 2 in the afternoon. I would like to introduce our guest speaker, Dr. Marcos Dieste, born in Spain, Saragossa, and studied economics in Spain and a PhD in operation management at the University of Padua, in Italy. He is currently assistant professor of operation management at the University of Padua, and his research topic is digital transformation and sustainability. Today's lecture originates from extensive research development identifying the negative aspect of Industry 4.0. After the lecture, we will open for questions from you. So we request that the question be posted via chat. Identify yourself with your name and the area of activity. Please, Dr. Marcos Dieste, it's your time.
Okay. Can you hear me, Archona? Everything good?
Yes.
Yeah? Can you hear me? Okay. So, well, I have some slides to present, so I hope you may see them. Tell me if you can see the slide, the red slide with the dark side of Industry 4.0. Is it correct?
Yeah.
Okay, perfect. So I will start my speech now. I'm Marcos Dieste. If we have some technical problems, Archone, please interrupt me and I will try to fix the problems, okay? Okay, so, well, I'm Marcos Dieste. I developed this study together with other Italian universities. This study is about the dark side of Industry 4.0 technologies. So those technologies that are well-known, included in the digital transformation. So we are talking about collaborative robots, we're talking about virtual reality, additive manufacturing, big data analytics, simulation. So these new technologies that are applied now or are starting to be applied now in industry, and that are a trend in research right now. We developed this study together with other universities from Italy. So I led the project at the University of Bolzano and the University of Padova, and I worked with some colleagues from the University of Bolzano and the University of Udine, always in the northern part of Italy. This study has been published in one of the most relevant journals in operations and production management. So this study has been published under this same title, and has been published in the International Journal of Operations and Production Management. First of all, I will present myself a little bit. So again, I'm Marcos Dieste. I'm from Spain, but I live in Italy. I've been living in Italy for 8 years. I got my PhD there in operations management. I used to work with lean production and sustainability, but now I changed a bit my research field and I work on digital transformation and digital technologies and sustainability. So I'm working at the Department of Management and Engineering. And well, actually, I've worked for some years, or I'm currently working for the University of Padua, which is one of the oldest universities in the world. It has now 800, more than 800 years. But I also collaborated in the past with the University of Bolzano, a smaller university, but very research active in Italy. And now I'm currently developing some research projects in order to make Italian manufacturing, which is world leading and world famous, more circular and sustainable. So that's the mix, the third picture that we see in this slide. This is the project that I'm currently developing and where we want to develop more sustainable industries in Italy. So let's go and let's see the topic of research. So what we have done in this research is to identify and to investigate the impacts of Industry 4.0 technologies, the ones that I said before, on sustainability. So to do this, of course, in research, so maybe some of the people that are hearing this presentation may think that research is just taking a research field and investigate, read, and apply some kind of methodologies. But for this research, we decided to carry out a systematic procedure by surveying literature and studies on the field, and also asking some experts about their opinions on the topic that we want to research. But first of all, we observed that some studies outline or suggest that there are some positive impacts of Industry 4.0 technologies on environmental dimensions and social dimensions of sustainability. So some studies says that the IoT, so the Internet of Things or big data analytics, may help to reduce resource consumption and energy use in factories, for example, or that some technologies may improve, like robotics, better working conditions and safety of workers. On the other hand, there is other literature which is more scattered, with less literature, less studies applied on it, which talks about the possible unintended negative impacts of these technologies on sustainability dimensions. As we know, the sustainability concept comprises 3 dimensions. The first is the economic, the second is the environmental, and the third is the social. So there are some studies that suggest that maybe an automated production, for example, could lead to higher consumption of resources, such as rare metals or energy, for example. Or there are other studies that suggest that digital technologies, may have social implications, negative social implications, such as the loss of privacy of workers, their autonomy, and therefore creating stress on employees. What we wanted to do for this study is to follow a method that is used in research, which is called problematization. And we used this problematization approach in order to challenge the general assumptions of the literature, so what the literature thinks about the research topic, and try to propose new assumptions that could be relevant fields of research for next steps. This is our main objective. So what we did is to try to formulate and evaluate these alternative assumptions, and try to develop new research propositions in order to guide further research of scholars and students, for example, in master's thesis. Maybe this could be interesting for your students or also for your researchers. So what we did is to divide this study in three objectives. The first one is to identify possible unintended negative impacts of Industry 4.0 technologies on sustainability, so on environment and social dimensions. The second objective was to find or to highlight some qualitative evidence on these impacts and try to find some motivations and corrective actions in order to avoid or limitate these negative impacts. And third, to develop and evaluate the assumptions that we are proposing. Now, this may seem confusing, but we will be following a structure and you may understand what I'm saying with this. So to do this, to achieve these three objectives, we followed the problematization approach, which has been suggested by Alveson and Sandberg. And this problematization approach, let's say, comprises 6 principles that we followed with different sections in our different sections of the paper. So, of course, if you want to read further information about this method, the results, and everything, this has been a published paper, so it's free access online. And if you want the link, you can contact me on LinkedIn, for example, or after the presentation, and I will send you the link of the paper. Maybe I will put it on the chat, or Archone, if you can put the link to the paper on the chat, and therefore maybe if someone wants to read it, he can or she can. So the first step that we took was identifying a literature domain. So what we did in this case is to let's say, do a preliminary read and review of important texts in the field of Industry 4.0 and sustainability. So we, let's say, study a bit about the topic. Then we identified and articulated assumptions. So we wanted to see what is the general opinion of these important studies. We wanted to identify which are the major assumptions that are held in these kind of studies. The third principle that we carried out was evaluating these assumptions that the literature is making. So identify some preliminary evidence that challenge the assumptions of this literature and see if it's worthy to continue with this problematization approach. We did this by identifying, I said, preliminary evidence of negative sustainability impacts. Then we developed the alternative assumptions, so alternative, let's say, propositions in the research by doing a systematic literature review on the negative sustainability impacts of Industry 4.0. I will explain this afterwards. Also, what we did is to relate the assumptions to audience. And in this case, we used a Delphi study. So we asked 43 experts about their opinion and what they think about what we have found in the literature. And we assessed their consensus level. We will see this afterwards. Finally, what we did also is to evaluate the alternative assumptions through the discussion of the results of the Delphi study. In this case, we wanted to see if these alternative assumptions that we are proposing, this new theory, if these are relevant and therefore can generate new theories, can be further knowledge that we have of Industry 4.0. So let's go back to the beginning. We said at the beginning that, well, first of all, let's start with the first and second principle. So identifying and underlying the underlying assumptions. So in this case, as I said, we reviewed the literature, the main literature, and we observed that many important studies in the field, and the most cited ones, the most used in the literature, suggest that there may be environmental positive impacts of Industry 4.0 technologies implementations. So, for example, energy use efficiency by using IoT, reducing waste by using sensors, or reducing material use by using data analytics, big data analytics, or artificial intelligence for carbon emissions. There are other social implications that have been underlined in the literature. So the learning of employees in companies could be enhanced through virtual reality, motivation and autonomy and empowerment could be also improved by collaborative environments through data sharing and so on. And safety and health could be improved by eliminating some heavy works and repetitive works with robots, for example. Then what we did is to observe also that through the third principle of problematization, we observe that there is a small literature that suggests that there may be unwanted, there may be unintended negative impacts of Industry 4.0 on sustainability. So some studies say that the literature is over-optimistic in this sense, and that there may be dark sides of Industry 4.0 on sustainability. So, for example, regarding the environmental performance, the energy consumption from data centers is really high, or the e-waste generation by using electrical and electronic equipment could be increased. Also, there are some studies that there are social implications, that there could be a replacement of workers by eliminating some functions of the company, or a loss on privacy and autonomy due to continuous data sharing throughout the company and throughout the supply chain. So we observe in the literature that there are unintended negative impacts of Industry 4.0, that further research is needed in this field, and that this could be interesting for academics and for practitioners and so on. And therefore, this suggests that it's worth to continue with the process of problematization, and that's what we did. The next step was to start developing the alternative assumptions. So to do this, we developed a systematic reading of papers. So we searched for papers on the electronic database, academic electronic database, and we surveyed some relevant studies on the negative impacts of Industry 4.0 on sustainability. And we considered only academic papers and scientific papers on research databases. We followed these 6 steps. And the first one was, let's say, defining the research questions, which was identifying a set of unintended negative sustainability impacts. The second one was to determine which papers are relevant or not in this field, in the field that we want to research. The third was to do the research by using some keywords that are important and that are useful to identify the papers that we want to study. On the fourth step, we applied the inclusion and exclusion criteria, so the characteristics that we want to have from the papers, and we selected 39 articles on the topic. Then we read them and we analyzed the articles by applying descriptive and content analysis, and we analyzed the findings that regard to unintended impacts, unintended sustainability impacts. Finally, we reported the results and we grouped them in 12 statements So 5 negative impacts on environmental performance and 7 negative impacts on social performance. What I do here is to present the alternative assumption ground, so the theory that we have found during this literature review. And what I said is that we found 5 negative impacts in the literature regarding the environmental dimension. These are the 5 negative impacts. The first was the consumption of energy due to big data, blockchain, and other technologies utilization. The second is the substitution of devices due to the implementation or adoption of robots, additive manufacturing, Internet of Things, that produce obsolescence and then material waste. The third effect is the material waste coming from consumables and other products coming maybe for wireless technologies like sensors, RFID, and so on, that may produce further waste, material waste. The fourth effect was related to the consumption of natural resources due to the utilization of digital technologies. So the use of rare metals and this kind of materials for building technology. And the fifth is regarding the energy consumption of the technology of additive manufacturing. So many studies say that additive manufacturing is really energy intensive. Then I said we found 7 effects on the social dimension of sustainability. The first one is one of the most controversial, which is the job displacement. So some say that the implementation of digital technologies may produce the substitution of some workers, and therefore these may lose their job if they don't reskill their or train in order to get adapted to the digital transformation. Then we have also the possibility of loss of privacy and personal autonomy due to the use of cloud technologies, the stress levels of employees due to an unhealthy work-life balance. So now we are able to work from home, and therefore we can work every day at every time, and this may cause stress. Also, that in this effect, some companies may become, due to the implementation of 4.0 technologies, may become more competitive in developed countries, and therefore they may backshore their production plants from developing to the developed countries, and therefore increasing the gap between developed and developing countries. So this could produce inequalities. Then some studies suggested health and safety issues by autonomous robots implementations. Others, headache and dizziness by the utilization of virtual reality or augmented reality. And finally, additive manufacturing could also produce some safety problems due to eye irritation and allergies. This is another and the last social impact that we found in the literature. According to the fifth principle of problematization, what we did is to relate these assumptions to the audience, to the interested audience. So we selected 43 international experts, and we asked them for each impact, for each negative impact, to assess the probability of occurrence from very low to very high, from 1 to 5, in the next 5 years. We asked them about the seriousness of the project, of the effect. So if they believe that this is very impactful or not. We asked them also to provide the reasons for these answers, so reasons for high and low probability and severity, and further explanations. And we also required them to propose some mitigation actions. This study took us 10 months to collect all data, and 2 rounds were carried out for data collection. in order to obtain convergence, so consensus among the 43 international experts, or at least stability, that responses are the same, and therefore we can stop repeating asking the same question. Here's the composition of the profile of the experts that we involved. We intended, or we wanted to involve experts from different fields with different expertise and from different countries. So most of them were from Europe. What we got some responses for America, from Asia, and from Africa. We got also most of the responses from practitioners in industry, so from the automotive, machinery, apparel, and so on. But we also wanted to ask the opinion of consultancy experts and also from academia, experts from academia, in order to have different views of the problems. And finally, we also asked experts with different expertise. Most of them had more than 15 years of experience, but we have also people with less experience in the field in order to have a higher range or a wider range of responses with different aspects involved. We developed this study, as I said, in a 10-month lifetime span. We carried out a first round, asking what I said before. Then we analyzed the responses. We developed individual feedback for each one by providing the results of the entire group, their previous responses, and then we asked respondents to think or to see if they want to change their opinion or not. Then we developed the second Delphi round until, I said it before, we arrived to a consensus or stability. These are the results that we found from the second round. So for each statement, we see here they will be appearing the statements, the negative impacts that we identified on the literature. We assessed the probability and severity for each one, and we also evaluated the consensus of each effect. The size of the box indicates if the consensus was high. So, for example, if the box is small, the consensus in this response is high, and therefore the experts agree, or mostly agree with their main response. And also, or if the box is big, the consensus among the experts is not very high, and therefore they have different opinions regarding the problem. The black line, let's say, indicates the median of the responses, and therefore the main result that was found in our sample. As we can see in the results, the environmental effects that we observed before are most of them supported by our sample with high probabilities of impacts and medium severities, and also with high consensus by our respondents. Regarding the additive manufacturing leading to higher energy consumption, this negative effect was rejected by our respondents for that they consider that there is a low probability and low severity of the problem, and there is high consensus. As we see, the box is small. For the social aspects, so from S1 to S7, we are also our results are more controversial, especially regarding the severity. As we see, we found less consensus in our results, but our respondents also support these negative impacts by saying that there may be a medium probability of happening in the next 5 years, and there is a high consensus in some of the statements. Regarding, for example, the probability of occurrence of autonomous robots leading to safety issues, the S5, this one was not supported by our respondents, so they think this may not happen in the next 5 years. Or, for example, there is another negative effect that was not supported. This one regarding to additive manufacturing producing eye irritation and allergies. This negative effect was not supported also by our respondents. What we obtained also for each statement, so for this one and for this one, is some qualitative evidence. In this case, for example, regarding the wireless technologies producing more waste, electronic and electronic equipment, our respondents thought that this is very possible that will happen, and this is a serious problem, and they reached high consensus. Our respondents also provided some reasons for high probability and severity. So, for example, that these devices have shorter lifespans and that companies pay limited attention in forecasting and optimizing the utilization of these devices. They also, because we have contrasting opinions sometimes, they also provided some low probability and severity opinions that, for example, many of the industries comply with the recycling regulations, and therefore it is difficult that the waste will increase, or that the batteries, for example, are now they have better performance and durability. They also provided some mitigation actions. So they provided firm-level mitigation actions, such as applying green design, or, for example, using durable and robust technologies, or applying circular economy as a supply chain level action. Or they also provided policy interventions, so providing incentives and legal frameworks in order to support the reuse and recycling of this waste. Also, for the virtual and augmented reality, our experts support with high consensus, and they believe the probability of occurrence in the next 5 years is medium and the severity is medium. They provided interesting, strong reasons for this issue to happen, but also they provided good reasons for the low values of probability and severity. So, for example, they were saying that the overuse of these technologies may produce headaches and dizziness, and that the number of companies using these technologies is growing, and therefore the probability of occurrence is also growing. There are also some reasons for low probability. So, on the contrary, some studies or some respondents say that virtual reality use is still limited, or that this may not create serious problems. However, our experts also provided some solutions to these problems. So, for example, allowing timely breaks to the employees, also involving the employees in the proof of concept of the utilization of the virtual reality device, or suggesting or requesting medical advice when applying this technology. Also, at supply chain, the cooperation with integrators in order to improve safety standards and maybe improve also devices. And also at policy level, improve safety regulations and standards addressing the applications of virtual reality in industry. Following the sixth principle, so we found the sixth principle is evaluating the alternative assumptions. So from our Delphi study, we found for these statements, so for the energy consumption of data processing, the obsolescence of and material waste, the wireless technologies increasing the generation of waste electrical and electronic equipment, and the consumption of natural resources, these negative impacts were supported by our sample of experts, and therefore we can provide an alternative assumption saying that Industry 4.0 may have unintended negative impacts on environmental sustainability performance. In parallel, also our experts considered that there is a social dark side, and that Industry 4.0 technologies may have negative implications on employment, that they may produce a loss of privacy, they may produce stress to our to employees, that in the implementation of technologies may increment the divide among developing and developed countries, or that virtual reality and augmented reality will increase headache, dizziness, and will produce headache and dizziness of employees. This statement suggests that there may be unintended negative impacts on firms' sustainability performance. On the contrary, some of our respondents considered that some negative impacts highlighted by the literature are not supported at least by now. So in the next 5 years, for example, AM it's not very probable that will increase the energy consumption, because the energy consumption is very negligible respect to the consumption of a manufacturing process, for example. That autonomous robots may lead to worker health and safety problems, and also they do not support that additive manufacturing produce irritation and allergy. Nevertheless, the problematization was a success, because we found controversial aspects and supporting aspects of the alternative assumption, and these ones need to be researched further. So what we observe is those aspects that got a high level of probability and severity. These support the alternative assumptions that we were proposing in the previous slides. Those that suggest that there is a low probability and or severity of happening, these support the underlying assumptions of the previous literature, suggesting that Industry 4.0 may not have impacts of on sustainability dimensions, or at least that they will improve sustainability. We also obtained different levels of consensus. So in this part, in this part of this chart, most of the experts agree with this, and in these were more controversial. So what can we do with this? So for example, for these statements that we see here, and that I have repeated several times, these alternative assumptions are partially confirmed, and therefore, are almost confirmed, because we got a high agreement among our experts, and therefore this could open new perspectives on the relationship between Industry 4.0 and sustainability. Regarding these negative effects, the alternative assumptions are partially agreed. So not all the respondents were in agreement, and therefore these are still controversial, and further research may be needed for this case. We will explain it further in 2 minutes. For these others, we found high consensus among the experts regarding that these effects may not happen, and therefore it could be rare that these assumptions may generate new perspectives on the effects of Industry 4.0 on sustainability. And finally, for this, our experts also reject that this negative impact, but they reject it with low consensus, and therefore there's limited space for new perspectives in this case. Moreover, we also found that there are emerging actions proposed. So if you read the paper, if you want the paper, I will send it to you. We have, I would say, hundreds of possible solutions to these problems, and also a very huge amount of evidence regarding positive and high probability of occurrence and high severity in our study. So our study is much longer. I couldn't present of the results here, but if you want to deepen on them, you may see them in the paper that it's a free access online. So we found some emerging actions, such as, for example, retrofitting or monitoring employee well-being. Some of the most important ones also relate to circular economy or outsourcing services like data privacy services, and others. Policy interventions obviously come from incentivizing and developing standards. We also developed some alternative assumptions, such as the first one, which is that there are actions that could mitigate the negative impacts on environmental sustainability, and a second one that says that there are also actions to mitigate negative impacts on social sustainability. To conclude with this, so we said that the problematization was a success because there are some our evidence from the Delphi study and our responses from experts say that agree with some points what we presented, and some of them were rejected. So some of them are still controversial, and therefore it has sense to continue researching and doing some pilots using these technologies in order to solve these problems, and there's room for further research. So coming back to the framework that I presented before, regarding these negative impacts that were agreed mostly and that had high probability of occurrence and high severity, further research could quantify these impacts. So how much waste is produced because of the implementation of Industry 4.0 technology? Or how many resources are consumed because of the implementation? Or what are precisely the effects of virtual reality or what are the influence factors of virtual reality on employees? Regarding this part, these problems had low consensus and therefore were more controversial. So further research could be used for resolving controversies and therefore finally resolve if Industry 4.0 produces energy consumption, or this is, let's say, offset by efficiency due to the appliance of models and artificial intelligence, or if it produces effectively obsolescence or unemployment. This is a very controversial problem, or stress and or global inequality. So further research could resolve these controversies. Also, this one, it's still needed to let's say to eliminate doubts regarding the safety of robots. So further research could be provided for this. Also, further research could be done to test the mitigation actions that were proposed by our respondents in our sample. So to conclude, well, since we involved several employees, several digital transformation leaders, academics, and so on, experts in general, we believe that the collaboration of different partners, stakeholders throughout the supply chain in the firm, but also at the policy level, is capital, is crucial to avoid unintended negative impacts and facilitate the transition to a sustainable and what they are discussing now, for example, in the European Commission, a human-centric digital transformation. So not anymore only environmentally friendly, but also human-centric. So now what the European Union is pushing is to put the human in the center when applying digital technologies in manufacturing context. You can find this paper in the International Journal of Operations and Production Management with this title. Here are the authors. And well, I hope this presentation was interesting for you. And thank you for listening to me. Thank you, Archone, and the other professors for the invitation. And if you have some questions, I can answer them after this presentation. Thank you so much.
Thanks so much, Marcus Dieste. I sent to you by chat, by chat, for 5 questions. Can you see?
Okay, yes. Can you,
Okay.
Archone, can you copy the link of the paper in the chat in the meantime? Puoi mettere
Yes,
l'articolo.
I already did this. Okay.
Ah, okay.
I
Okay,
already.
so I will read the questions from, for example, Maria Eduarda. Sorry if I pronounce badly the name. Okay, so aeronautical engineering student. Industry 4.0 is a hot topic currently. What is the way forward for a better interaction between sustainability and Industry 4.0? Do you think that the popularization of this topic is positively influencing the industry, building a more sustainable mentality? As an aerospace engineering enthusiast, I see that one problem today is the accumulation of garbage in Earth's orbit. How can industry... this is very interesting. Okay, so the first one is a hot topic, yeah. And well, currently, a lot of governments, for example, the Italian government, and I'm involved in that, is pushing that the joint implementation of digital technologies, so Industry 4.0 and sustainability. So this is a hot topic that governments and also companies, because also customers are requiring sustainable products. And Industry 4.0, we have now new technologies that could make your company more efficient. So let's say demand is requesting sustainable products, but also requesting products at a low price. And therefore, in order to be competitive, companies will have to join these two paradigms, these two concepts. So let's say demand is requiring this, and also policy institutions are supporting these timely concepts. Okay, I think I can move with question number 2. Do you think that the popularization of this topic is positively influencing the industry towards building? Yes, for sure. So in this paper we are just presenting some of the negative outcomes. It doesn't mean that all the effects are negative of Industry 4.0, but in order to be more sustainable, some of the dark sides, the dark effects of these technologies need to be addressed, especially the social ones. And actually, the European Union is pushing for that. Third question. I hope I am answering properly to your questions. And as an aerospace engineering, I see that one problem today is the accumulation of garbage. How can Industry 4.0? Whoa, this is an interesting issue. So, well, collaborative robotics could be useful for this. Maybe using robots that work together with astronauts in order to collect this kind of garbage. Of course, this is a very difficult issue because we are involving also space industry, and these kinds of things are very risky, and it's a problem difficult to solve. But maybe robotics could be useful. Also, maybe weight traceability of this garbage through sensors. For example, we can try to let's say monitor through sensors this garbage in order to try to collect them easily and the most efficiently way, through to artificial intelligence. So there are some applications, but for sure the technology that the NASA, for example, or the space agencies are using, I'm pretty sure that they are really advanced and are up to date to the 4.0 technologies. Okay, let's go for a question from Archone Viaggi, assistant professor. Your research resulted in important work recognized by academia, being published by important scientific journals. What do you recommend for ours to follow you? Well, so after working for some years in industry, I wanted to do some research and to, let's say, to provide lectures and to teach students in some different topics, especially in operations management topics. So if they want to follow a path of research and of academia, I think they need to, first of all, as I see, it's very important to learn a language, a second language. So English is very important. Also in South America, Spanish is very important. I also speak Spanish because I'm Spanish. So having a language, a second language or third language, it's very relevant. Also, well, try to go abroad. Go abroad is important. What I've done, I'm talking about what I've done. So I took a scholarship for a PhD in Italy. So I first get the scholarship and then move to Italy in order to carry out my PhD. So I think that also opens your mind a lot. A PhD is not an easy path, but you, after you have accomplished it, your mindset and your way of thinking is really different, and therefore I think it's very important to consider it if they want to follow my, I wouldn't say my example, but my experience. Leandro says, we consider the different generations, baby boomers, millennials, etc. Would you believe they would deal or suffer these effects differently? Well, in some senses, yes. Well, some people say that our generation will live worse than the previous generation, so we are already suffering some of these effects. But it is important to consider that oldest generations may have issues, and actually we are seeing that in some industrial companies may have issues when it comes to learning new skills that need to be applied and that are needed to use this kind of technologies. So reskilling is is a very relevant issue in what regards to the implementation of digital technologies. Okay, and acceptance of the employees. That's very important. Okay, the next question, 1 second. I will read it now. Okay, the next question is Isabella. Do you believe that younger generations are prepared to deal with the negative side of technologies, or they tend to ignore these problems? No, I believe younger generations are very concerned about environment and that they want to solve these problems. So I believe younger generations want to at least to deal and are concerned about preservation of the environment. So, well, my students are, and we are also pushing to recycle and to do what it takes to improve sustainability in our to do it when it comes to, or in what is in our hands, so what we do daily. But we need to do our part and try to improve sustainability in our small range and our small possibilities. And I think there are no more questions, Archone.
So, this is the question.
Okay. I put the link to the paper. If someone wants to download it, you can download the PDF.
Okay. I sent by YouTube
already.
too. Okay. Marcus Guest, thank you very much for sharing your work with us. I'm
Thank
proud
you for
to have
inviting me.
worked with you and seen your success. Okay. I hope everyone took advantage of the opportunity. E good afternoon. Marcos,
Thank you,
grazie
Arsone. Thank you
mille.
so much for the invitation. Grazie. Hopefully, we will see ourselves in presence sometime. So it would be great to see you
Okay.
again, and maybe one day to be there in Brazil in presence, presenting to all of you. Okay.
Okay. I hope so.
If one last thing is, if someone needs something, of course you can contact me on LinkedIn, Marcos Dieste, and or by email. It will be easy to find my email somewhere. So I would be happy to answer queries and
I
questions.
sent by YouTube.
Okay. Okay.
Okay.
Thank you, guys.
Thank you
See ya.
so much. Ciao.